We're going to go ahead and take a look at number 69 from section 4.1, exponential functions and their graphs. The function that we've been provided reads f of x is equal to 2 raised to the negative x minus 3. One of the first things that we need to do here is we need to identify how we are transforming this function, or how are we moving it along the coordinate plane. So first off, I'm going to note that there is a minus 3 here. Note that the minus 3 looks like it's been tacked on at the very end of the function. So in other words, it's not happening inside of the function. With respect to exponential functions, if it was happening on the inside, then you would see that subtraction happening in the exponent position. So this is a vertical shift, and since it's a minus 3, we are going to move down 3. And then also notice the negative in the exponent position. This tells us that we're going to have a reflection, and the reflection is going to happen across the y-axis. Now I know it seems a little bit counterintuitive, but let me take a minute to explain this. The reason why it's reflecting across the y-axis is because essentially what we're doing is we're taking our x value and we're going to switch the sign. Notice that the negative is impacting our input value, or our x value, right away. We're not doing any sort of calculation to the x. In other words, we're not adding anything to it, subtracting anything to it, multiplying, dividing, or taking an exponent, or evaluating an exponent is what I want to say. Notice we're just right away, we're switching the sign on the x before we do any sort of additional work. So essentially what I'm doing then is I'm changing the sign of my input value. So the y-axis actually acts as a line, a dividing line. So half of the x values on one side, well, the x values on one side of the y-axis are going to be positive, meaning in the first and fourth quadrant, and then the other half of the x values on the other side of the y-axis are going to be negative, meaning those values that help to create the second and third quadrant. So one of the first things that we want to do then is let's just kind of strip away what we have transformation-wise, and note that our parent function is 2 raised to the x. That's going to make it a little bit easier for us in order to create a table of values. Because note that there were a couple of points that we were able to pick out when we were evaluating the 7 different characteristics that make an exponential function an exponential function. So one of our points is going to be at 0, 1, and the other point that we would have would be at 1, 2. So again, note that the reflection across the y-axis, that's going to change the sign, or yeah, it will change the sign, or I guess flip the value in a sense of the x value or our input value before we do any other sort of evaluation. So what we're going to do is we're going to flip the sign, and in other words, by flipping the sign, we're going to multiply all of our x values by a negative 1, because that will change the sign on our x values. We're also going to move down 3, and what that means is if you were to move along the y-axis, our y values are going to be impacted. And the reason why we move along the y-axis is because it is our vertical axis, which means that we would move up and down along it if we wanted to travel on it. So this means that our y values are impacted, so we will subtract 3 from both. So our new points, negative 1 times 0 is 0, 1 minus 3 is negative 2. Negative 1 times 1 will be negative 1, 2 minus 3 gives us negative 1. So these are the 2 points that we will need. We'll go ahead and add in a coordinate plane. Okay, not too bad. So we'll go ahead and plot our points. So we have one at 0, negative 2, and then at negative 1, 1. One other thing that we want to note here is that we are going to be seeing our asymptote change here. Usually our asymptote rests right on top of the x-axis with exponential functions, but we did a vertical shift. We pushed everything down 3 units. So that means that our asymptote will move down 3 units. And the asymptote is helpful to have here, so we know how low our exponential function will actually go when we're drawing it. Okay, so from here we can connect the point that is acting as our y-intercept in this case is going to kind of tell us when to pivot, and then we get really close to that horizontal asymptote without touching it. And again, I understand drawing this by hand. That's not always going to be possible. But there is the graph that we should produce. Notice that it looks like it's decreasing, but again, that is a result of the fact that we reflected it across the y-axis. If we didn't have that reflection, so what I would say is go ahead and graph this without the negative and see what would happen. You would notice that it is an increasing function, but again, the reason why our answer looks like it is a decreasing function in this case is because we are changing the sign of our input value before we evaluate. Okay. I hope this explains any questions that you might have had. If you do have any other questions, please come see me.